Good afternoon. Good afternoon, everybody. This is Engineer Suraj Singh speaking from Bharat, India on this day, May 23rd, 2021, Sunday. Today morning, there was a problem in streaming this video. I tried many times, but I failed. I tried then direct talk, I failed. So now I tried in afternoon. This is now about 3 p.m. 15 hours of May 23rd, 2021. And talk is Civil Field Engineering COVID-19 Impact on Workers, Designs, Construction, Method, Contracts, Organizations, Communications, Coordinations, Quality, AnnexSL, YB, and Quality of Concrete and other materials. And this talk is addressed to you people for your convenience and to have a appraisal of what's happening in quality world. It's certification you have seen, and this is chartered engineer certification, and this is this certification of chartered engineer, which states something, and this is a fellow member of institution of engineers, which is this one, which also tells something. This tells something as well. This is only for reference I'm putting in, so that we should understand meaning of the certificates, because these certificates are not only for showcase. These certificates must be used in field while working. These are competency certificates, and this must give you consistency, quality, and also issue of COVID-19. First we will discuss this, and later we'll jump on to other issues. Let's start with COVID-19 related calibration. This is impact on HSE engineering. Impact on HSE engineering, that is health, safety, environment, engineering, and you can say controlled by ergonomics support, controlled by ergonomics, and you know what's ergonomics. Many times I explained to you through various websites, through various references, what is ergonomics about. Energy use, optimization of energy for activities, that's called ergonomics support. Now, construction workers grief handling, that's not part of this. How to handle our construction workers who are impacted by COVID-19 related issues, and COVID-19, which has been for more than about 1.5 years in its existence. Its impact on engineering is very much. Current impact to the engineering is very slow because of lockdown, many reasons. I'm not going to that. That's control measures. Now I'm going to engineering world only, where direct impact on site does. It impacts on health, it impacts on safety. Health and safety are very much important issues on sites. Health and safety, because without health and without safe conditions, safe environment, work cannot be done. And if you do, you'll meet problems. And ergonomic support is such that it gives something which is very much convincing. Without ergonomics parameters, we cannot do anything. It's a such science. It's a science like engineering. It has many parameters, it has many empirical directions, and this is what it applies in all activities of engineering construction, and even in offices when we work on workstations, it applies there as well. It applies in general life, when you walk on road, when you drive car, when you do something, some activity, whatever you do, it applies there, which you may not realize in our working life how it's applied, but it applies. That's true. What should be your eyes location, what should be height, how you should view at computer, non-instant screen, how you should in chair, or how you should sit in car while driving. There are various required poses, but generally we don't follow. If you might have noticed how a driver driving car sits the backside. Why his waist should be vertical, upright positions to sit according to lessons I got in driving training. But every person sit comfortable. Nobody sits straight. People sit a little backwards. It happens when you walk in different positions. When you stand in different positions, and this imparts, you can say, undue stresses to body. And when I don't sit vertical, upright while working on computer, it also gives problem to me and to you as well. I'll discuss this later on. Now, what I'm trying to say that ergonomics is different type of science. It's not very well developed till now, but whatever development it has achieved, you have to understand that it implies its effects are experienced on health as well as on safety conditions when work is done. And environment, very well, air, water, humidity, dust storm, and all that is all there. Now we have workforce in every site. On every site we have workforce to we call crew, and every activity has a different proportion of crew. For excavation, for blinding, for concrete, for form work, for steel, for block work, for curing, or whatever activity comes, material handling, or whatever activity. There are hundreds of activities on every site, and every activity has got different compositions of crew, and we have to allot our workers accordingly. We can neither allot more nor allot less. If we allot more, means it's waste of manpower or workforce, and if we allot less, we can't get work done. That's the problem. So we have to understand that problem, keeping abreast COVID-19, how to handle those issues. We have to think on that, how to reorganize frontline teams in such a situation so that all workers remain safe. How to reorganize frontline workers, frontline teams in such a way, in such a situation, so that all workers remain safe. It is responsibility of entire engineering professional community to contemplate on site working issues that would be impacted upon due to additional protective measures, requirements to keep off COVID-19, contractions on to workers. Many activities are critical in a sense which do not permit to maintain social working distance as well as cause inconvenience, wearing all PPEs full time. I repeat, it is responsibility of entire engineering professional community to contemplate on-site working issues that would be impacted upon due to additional protective measures, requirements to keep off COVID-19 contractions onto workers. Many activities are critical in a sense which do not permit maintain social working distance as well as cause inconvenience, wearing all PPEs full time. Such activities must be analyzed and thought of to resort to safe actions. Many be output affected, maybe output affected. If we don't do that, if we see we have some output while people work sitting closely, working together, but when we keep them off 2 meters away each other, it would certainly affect output to be given by them. So we can say maybe output affected on such activities, but health of workers is more important than output in relation. Of course, if we deteriorate their health, we ruin their health, we don't expect any output, and we have to spend money on their medical treatment, on their sickness, for their sickness, and also we have to allow them leave we have to spend a lot. So workers' expenses on health that we make outweigh, and therefore we should be thinking of precautionary measures, because curing is very expensive, and you can say loss prevention is better. Workers must be allowed additional pauses to maintain physical equilibrium, keeping abreast COVID-19 impact in combination with high temperatures, with variation in humidity. Concrete pouring is very critical activity, because it's first of all very expensive material, and it is chemical reactive material. Concrete pouring is very critical activity that requires different methods for different pours and varying strength of crews. Thought must be given to all such critically varying activities. Most of these activities are externally located, and therefore social distancing in group working raises question marks which must be resolved for efficient work. Why is that? See, we are responsible people, and engineering community is having its responsibility to keep work according to standard requirements and time arrangements, and we have to keep cost also within limits. But on top of that, because we use workers for every activity, and responsibility of their health and their safety comes to us. That's engineering professionals that we have to keep in. We have no right that due to our ignorance, due to our negligence, our workers are COVID impacted, because this is not easy to treat worker once COVID-19 is contracted by that worker, but it may lead to death of that worker. There are so many activities in engineering sites, construction engineering, particularly in civil. Generally, activities that we perform, all activities are done in beginning under no cover of roof. Under no roof, you may take activity of excavation. Before that, you may take activity of surveying, and then you can say removal of earth, excavated earth. Then you may say foundation work. Whatever foundation we do, that's in open, no cover. And then we do fabrication work of reinforcing bars, we do fabrication work of form work, and then whatever we do concreting itself, and erection of this form work, and placement of steel rebars. These are very basic works in structure, and you may say from starting whatever site and involving all structural works, particularly RCC works, all are done for long duration on whatever project. You can say 60-70% time is taken by such activities, and on these activities no one person works, hundreds people work, hundreds and hundreds and hundreds. Let's say there is no work which can be done by one person. A group of people are required, and that's why I say they work very closely, talking to each other, sitting together. There is no safe distancing. It's not easily done because they have to converse with each other while working, and therefore question arises, you cannot all time stand with them to keep off. They must be educated properly. Now in this entire scenario where COVID-19 works, and maybe in future I don't know what shall happen. So contraction of COVID-19 by such construction workers is very much positive, answer, means they may be. And there are, all these activities I'm telling you can put them in problem. And it's easy to say social distancing or working distances. Saying is easy, but its supervision, it needs very constant and in extensive supervision all time. Means you should have some person there exclusively deployed for this corrective measures during work, because when workers are busy, they don't remember all this. It's not only social distancing, also you have to keep their immunity levels higher. Means they must be given an environment where work is healthy, work is easy, and they don't feel fatigue of whatever type, any kind. That environment requires to be created, and this can be done particularly in hot weather conditions. Then they should be given some cold drinks, some tea, hot tea, or whatever is rest pause, frequent rest pauses, for so that their sweating body can dry itself. Means it depends upon temperature and requirement and lunch hour, other hours, that they cannot be left unattended. Health, immunity must all time stay with them. We use PPEs, all workers, including staff and managers and organizations. PPE is very important. It's nothing new for them except that they have to use mask. But for majority of workers, mask is already used during bad weather conditions or during in areas which are suffocated one. Mask is used, and many other PPEs are used. So PPE is not a big issue, but in this case it's a must. Such activities must be analyzed and thought to resort to safe action, such they are doing. Of course, you can say if we just implement these requirements, there will be some reduced output by these workers. Well, I can say I'm not very much worried about this. Reduced output may be maximum between 20% to 30%. And when they are used to do such kind of repetitive use, that 20 to 30% may also drop to 15% or 10%. It's a question of time. Just like they use their PPEs, they can use this also. You can consider that social distancing is also a PPE, and they have to keep washing their hands, sanitizing site whenever required, because sanitization is very important. We have to clean our toilets, site toilets. We have to keep all site tidy, which is principle of safety. Not only site but also their yards where they work, their living camps, life camps. All must be sanitized, kept hygienic. You can say work locations where they are put in, those areas must be kept tidy full time. And these are, you can say, also we do in safety, health and environment. All this is done, but now in this case especially it is to be done, and we have to keep them warmed up. Without hunger, with the hunger we don't allow them. We have to keep them food in time, give them food in time, give them water in time, rest in time, and no overwork. Okay, overtime maybe 2 hours, 3 hours, in place of 8 hours, 10 hours, 11, not more than that. Your rest is also must. If they don't sleep properly, they stay burdened, stay unhappy all day, and that should be avoided. Temperatures in warm weather conditions, when temperature is 45, 46, 47, 49, we have to keep them according to requirement, according to demand of high, hot, humid environment, or it may be dusty. We have to take all measures that are required in safety, health and environment issue You know, in high temperature conditions, sunstroke is very important. That can also cause problems. So we have to keep that in mind, that in addition to already existing issues in safety and health, we have to think over COVID issues also. Concrete pour is done in many ways, and frequently it is done. Sometimes it is a small quantity, sometimes it is medium quantity, sometimes it is high quantity. It may vary from 2-3 cubic meter, or even sometimes 1 or 2 cubic meter, to 50 cubic meter, to 100 cubic meter, to 500 cubic meter, or more, like that, 2000 cubic meter, 2000 cubic meter, depending on material we are going to pour into member. Column, for example, or beam. Column, for example, is very small quantity consuming element. Wall, for example, is also another small quantity material consuming element, but suspended slabs, foundation slabs, footings, all these require considerable quantity of pour when many members are done together. Sometimes concrete is done for a couple of days, for example 2 days concrete, 48 hours concrete, 72 hours concrete. Sometimes it is done for 1 hour, sometimes done for 4-5 hours. It depends on that amount, quantity and delivery. And when we say people stand together, again I say, on column top, on platform, they stay together. In that case, we have to keep them again tied up with PPs, and no one can stand distant, but they have to stand. Means we have to arrange accordingly, because when they pour concrete, they have to see in column itself where it is, and apply vibrators. So one man or two men apply that. One handles vibrator, one handles, you can say, nozzle, and there are others who handle pour through pump, boom, or crane. So there's a group of many people working at one location, and it's not possible that at that time they apply social distancing, maintain social distancing. So we have to keep something, means they must use such masks which can save them. They may use shield also, face shield in addition to masks. Means when they work on foundations, say 50 foundations are casting, 40 foundations are casting, and no foundation stays together. One foundation is here, another one is other place, maybe 3 meters, 4 meters, or 5 meters. So we have to keep, means in such a way we should do that they do not sit together in one place. If they sit together, they may be not more than 2 or 3 persons at one place, and foundation is already 1 meter, 2 meter, 3 meter, 4 meter, like that. So we can ask them one sitting little distance from here, and then they work for fly vibrator, and then mason finishes all that by wood. Then like this slab also stay where many people stand, maybe 20 people sometimes, 15 people sometimes, and they try to stay. So we can do, means we put them in groups, or we can say, okay, we will not do using one pump, we'll use 2 pumps for this, and we shall have to chart out our pour plan in such a way, depending on other quality issues, quality controls. Means we have to completely rehaul our plans, concrete plans. And concrete is very important material. In open it is done, to weather conditions it is done, and generally it's done every day. If not every day, every alternate day we do that. You understand what I mean. Concreting is very, very important item for structural engineering. So we have to apply our contemplation on such issues. These are very, very critical activities when we have to do structure, and these are all external, I'm calling external, because these are done in open air. These are not done in covered areas. Covered area activities come after structure is ready. This shall be for those finishing items, for walling and for electrical, for mechanical, for others, plumbers. Those activities come later on, and there may not be that much problem. As problem lies in this. Fact remains that if you don't get RMC, then we have to be on site, and when people are working on RMC, they also have to take care. So this is what I'm saying in this. Now, I say for COVID-19, which is a powerful attacker on humanity, entire humanity. Related facts are there, some related facts. That is, many heavy construction activities may require forced ventilation or other inputs for workers, which engineer has to contemplate heavy activities here. Now, just for information, I'm giving this statistics and data. 50% world infections about COVID-19 is occurring in our country, Bharat, India. What is miscellaneous medicines? We don't have ample medicines, and we are in real trouble. Our facility issues are significant. Oxygen is a question mark, which is short in supply for shortage of cryogenic transport carriers. Hospitals is a question mark. We don't have plenty of hospitals, and not meeting unexpected requirements. We don't have beds. If no hospitals, means short of beds we are. Not available to meet demands. Yes, we are not available. These are not available. Beds are not available. Doctors are short, but they are working too hard. Nurses working too hard. You cannot complain. Unfortunately, we have in our country lost around 1,200 doctors due to COVID-19. It's a great loss. And health workers working too hard. Ventilators, question mark. Infections, more than 1 million daily. We are getting, leave aside formal data, 1 million on average we are getting every day, and that is, you can say, more than 10,000 every day. Whatever is government data, that is based on 25% only, 25% testing. So we have to use around 4 times what data they give and establish our thinking, our statistics. Now, experts assess more than 1 million persons have already left for their permanent home. This data is calculated one, means it's assessment, you can say. It's not recorded data. This data is calculated one. For only about 25% have been tested, which means a multiplying factor for 130 crores population can be used. That is, numbers tested. If we divide numbers tested, means those have been tested of COVID, those numbers of persons, and we divide 130 by 130 crores, we get some coefficient, or we can take other ratio also, but let us say percentage people tested, and we can say, let us say 25% people have been tested so far, which means it should be 100%. So 4 factors there. 100 over 25 is 4. 4 is multiplying factor. If 10% people were tested, it was 10, and 100 10 times. So if you take 33% people tested, means it will be 1/3. So that factor can come out this. So currently for 25% on an average, you can say a factor of 4 can be used to multiply what data we receive from records from government. So that's what I'm saying. If you say, now we can say about 2.6 crores. 2.6 crores cases have been registered, you can say, out of 32 crore people. Let us say 2.8, or let us say 3 crores, means this is, we have 3 crores already infected. And how many tested? Only 35 crores or 30 crores. That way we can understand how many more must be infected with. So my assessment is that it's maybe it would be 30 crores by now already contracted. Now no worry is visible for all villages. I'm talking of villages in India, maybe 700,000 or 7 lakh villages, I exactly don't know, but where no medical facilities for testing and hospitalizations are available. That's a great point. We have to concern with that in our villages, which are in lakhs and lakhs all over our country, no adequate facilities are available for purpose of testing as well as purpose of cure or whatever we do, hospitalization. Nation that is unable to test its population against COVID-19 is in a shameful state. So we are in a shameful state. To be very frank, we should speak it. There's nothing wrong with this. After all, it's not political issue. It's not money issue. It's issue for existence of human in our country, existence of our people. If we cannot test them, means we have no standards, we have no commitment. I am blaming everybody, all organs of government in this regard. So we can say I'm using I should say nation that's unable. We are nation, Bharat, India. If we are unable to test our population against COVID-19, it's really shameful state of our affairs. It's already 450 days around, or maybe more, whatever it is, maybe 14 months or 15 months. We have been able to test only about 25% population. So what's our speed of testing? We could not learn it still now, and we are not very serious about this, really, not very serious. And it's really very much, you can say, tragic, yes. Miscellaneous, if you see cremation ground, graveyards, no place for dead bodies to be put into fire or to be buried. But what about poor? No concern. I question, does any government exist? And my answer is seems none exists, for no actions are seen. What we should do? Should we hang ourselves? No. We have to test all immediately. Why not entire population tested in 14 months? Isolate those infected. Yes, they should. Shall we survive? No scheme for testing and immediate inoculation by government. Really, it's very, very strange, After all, what we have achieved, if we have lost more than billion people, according to calculations, government itself says about 3 lakhs they have lost. So about 3 lakhs means it is going to be about 3 lakhs in some time to come officially. We can multiply it by factor 4, let us say. So already 1.1 million people, according to our calculation factors, have left our country and gone to their permanent destination. There are thousands and thousands bodies lying in sand on banks of rivers, which could not find proper place for graveyard, for graving, for burial, or for funeral. So what can we say in this condition? Really, it is terrible. Really terrible. I can't answer this, but it's human. If human stays in such condition, which is really intolerable, non-tolerable, I don't know what to comment on that. It's really very tragic. If I may see, so I put file here. Let me see if I can find that file. Just hold on, please. I'm just going to my mail and see if I can find that file which I put today morning, just to have information about that. And that file is somewhere here. I will show you that file. This is COVID URL, and that file is, well, first I'll give you this file. This is just to give me minutes only, please. Just opening that file and putting, and you know, it's not coming down till now. Let it come. Resolving cost. By resolving cost, it is come. So it is come. I'll show you this file. Let me take print of this, and you can see this file usually. And you can see this file is coming up now. In PDF format, taking print, and we'll show this file, which is today's file, and this is today's update. You may see this is very current file, today's file, page 315, page 4, so about 15 pages is printing out. Page 3 is over, 4 is over, and you can say now 5. You may see this now coming 6. Then you may see it's coming, of course. Meanwhile, we can go back and see our file is talking about, and I take this towards now. It's very serious issue, believe me. It's part of engineering and not part of, it's different, but I consider it as a part of health, and it's really very wonderful. But think about this, and I think what's happened? It's gone. It's now 11 pages. I was doing 11 pages, 12 pages, just gives few seconds. 13 pages. Yeah, 15 total, 14 pages, and it's end, I think. 15 pages. It's printing now, and it's coming then. I think it's coming now, and it's coming now, I think, and it is coming. So I close Excel file here. Hold on, please. Let me save this file first of all. This is file here, just a minute, please. Because it's very, otherwise I lose this file. GHL and GHL comment here. So I save this file in 22. So this file is saved in 22. Okay, fine. And I have to save this file also. So this Excel file, I'm sorry, not this one. Other one that is here. Yes, this is that one. Excel rows. This file is here, but now it is real file. File where I'm saving this, and this is here in called Bharat, and it goes same way as that's one. This is 20, 22, 5, 21. Okay, this is that one. Alright, so this is that file. You can see here, I explained many times before that this data is based on, this is days, this report date, and this population, and these 5 informations here you can see in highlighted one. This is government information, this is total test update here. This is total test update. This is daily test conducted. This is infection update. This is daily positives. This is that update, that's update. And these are here, you can say calculate this multiplier and infection. I applied to infections daily and death daily. And here is, you can say, vaccination detail, you can say here. And all these goes above, and we'll find that this file is having backup of 20 to 45 days, that is yesterday one 22/5/21 448 days. And here is, this was total those tested in our country, which is about 32.6 crores, which is 25.144% of population, and 74.86% is still waiting for test. No test is done. This is, you can say here, these are, this is, you can see that here, this is that till now 295525. This is here today's infection. Daily test conducted, infection update, and daily positive. This is daily test conducted, 20,66,000 yesterday. This is, you can say, infections update here. And this is total infections, means out of these 32.6 crores, we got 2.628 crores infections, which is going to be 3 crores soon, maybe in a few weeks. And it says that this is that, which is 25,7299, 2,57,000 something according to government, which is 12.45%. This is 12.4% of this quantity, means 2.57, I'm sorry, 2,57,000 cases per positive, that is 12.45%. That is here, this is that 2.57 lakhs cases, 2.573 lakhs cases were declared out of those tested, which is this one, out of this one, 20,66,000, which is 12.45%. And daily it varies, you can say here. And this is number of deaths till now, number of deaths. And yesterday 4194 were declared dead officially. This is first stage. These vaccinations were done yesterday, and this total vaccination, which is about population, which is 14.875. If you apply this to 130 crore people, it's combination of both stage 1 and stage 2. Now 448 days gone, and we have not done anything. So let me take another file also here, just a minute. Let me take another file here also, which is here, and that's coming down. Let me see how it comes. I'll show you other data also. It's just a question of 5 minutes, because we should be with every data. And this is that. Let me print out of this. This is print out of this. Okay, this is print out here. So this is print out of this data, and I can see, you can see that one, right? Let me save this file first of all. Why it shall become a problem for me. Save 22, I put in there 22. This is done. I close this file. This is the other one. I'll save this files as well. That's just a chance for me. I put in here 25 here, so I put 22 here, 22 here, and this is gone. Okay. So you can see this data. You see, this is figure that gives number of positive cases on this day, and this is calculation for 245 days, which I showed to you here. It's 245 days. This data which is started here from this data says we got this, and say this is for May 21st. This is for May 21st and reported on this one. Okay, now you can see that way. What actually is important is all this because I'm giving in here. You can see, for example, I'm writing here conclusion means assessment based actual figures for infections and deaths, etc. Like that, I give this data every day. You'll see that this file is available, and these are the URLs that I put in there, and I put that data in. It's like that I will guide you. So we close this file. This is available on in the you can see this file here. Important point is I put this factor here. For example, I'm taking this factor here as multiplication factor. I calculate every day. For example, this is the factor here, and there's so many informations, and I'm just showing you this file. I work about this information in this file. 7 days average here, like that, and you see graphics also there. Graphics. Let's say I can say like this is graphics here. Various curves are shown. So this is that file. I close it. I think you got it. Okay. So I close this file. Now I close this fellow file also. This file also. Now we are on quality. You see, for me in person, quality is very important issue that I consider. Very important issue. There can be no compromise, no agreement on adjustment of quality. No, I don't accept that. Quality approach. Quality approach definition I just try to make out. Definition is already available in every project. You can go through documents of every project and you will find various quality issues. You will find documents, project documents which contain quantities as well as required quality. Required quality varies from project to project. Here what we are saying is quality approach defined. What should be that approach? In brief, I want to define that. For general consideration, I'm not saying this is consideration only. It's quality required everywhere. Quality required everywhere. And in engineering, it is a must. Quality required everywhere. In engineering, it is a must. Is it? My question is, it is a must, I say, in engineering, though it is required everywhere. And I say in engineering it is a must. Is it? My question and question and question and plus you have to answer. It says, what does it say? For me, system quality, systems quality, then it is individual quality, then it is product or element quality, attitude quality, dedication quality, commitment quality, other parameters. All other parameters. We should not forget that when we say systems, it's not a word, it's not a terminology, it's complete scenario we work in when we say systems. It's complete scenario from desk to work site. Desk to work site. I still remember somebody used to call us, you are desk engineer or you are site engineer. It was when I generally, there were some mechanical and some electrical people in that company. And it was, I'm talking of about 1983, 84 when I was in Libya. So at that time I was too young and I could not understand these terms. Then you used to ask me, you're desk engineer or you're site engineer? Well, I was a little confused. So where is desk engineer? I never knew. But they just used to call desk engineer. In those days, there were no desk for engineers. Just sit and design and think or do plan something. So there were no computers. There were no, you can say, workstations. Nothing in those days. Then I was surprised to get my question that you're desk engineer or you are something else. Well, just it was a reference only, nothing to do with talk now. When I say systems means it's complete scenario for destination project working. I'm calling destination project, which has a meaning. What is a destination after all? For design engineer or before design engineer, some honor, government, whoever be honor, design engineer and planning engineer or whoever involved therein on engineer's end, and also contractor, whoever work there, all those, and all workers. This you can say whoever are stakeholders in charter of that project. Destination of that that work is destination of all their joint destination, all parties involved is project. That is, we have to achieve, we have to deliver. And if we are not able to do that project, then we can say we have failed. Our design did not work or could not work. Our contract could not work and we failed. So that's what is system. Don't consider system of construction alone or system design alone. This whole circuit, I can say, from initiation or from conceptual stage to end of project, completion of project, so that that project starts into operation. That is systems equality, systems quality. I am talking of that. And in that system, what are included in? In that system are infield individuals, infield products. Products means products we are going to make or produce, or products which are used for producing those new products. So I'm calling them element quality. Then attitude of everybody who is involved in designs or in all systems or in other disciplines like planning, safety or quantities or bidding, whatever, and all those involved on those supporting products and all other who are working on those projects, who are going to work, and what level of dedication they adopt or they have to contribute to that project. And commitment. Dedication came only if you are committed. So commitment is also very important, and commitment as well as other parameters which are unlimited. Commitment here means we commit that we shall do this project, and we say we shall do this project on whosoever behalf. I should say all stakeholders, they say we will do it, that destiny will achieve, and that destiny, that goal is project. This is what I mean to say. So when we talk of quality required everywhere, this means also it's required everywhere in this scenario. Systems, individuals, product elements supporting one, and attitude of dedication, commitment, and all other parameters that we can say would be used on project, like human resources, equipment, temporary works, preparatory works, supporting parties, and everything, you can say procurement, whatsoever we have to do. All these points which cannot be defined in sentences would work in quality. Information must be available for everything, and not only available it must be, but also it must be utilized. It must be utilized, or else that information is meaningless. This is one part. We say design of structures. Designs of structures and others must be qualitative and reliable. It's very powerful statement here. It's my own brain child, you can say. Though it's not my exclusive child, it should be every engineer's brainchild, or to follow up others' brainchild. Designs of structures and others. Others means not only structures we are concerned with designs of all disciplines, finishing disciplines. You can say architectural discipline, etc., electrical discipline, HVAC discipline, vertical movement discipline like lifts, elevators, and whatever else. So many sub-disciplines which are to be designed. So that's what I say, designs of structures and others must be qualitative and reliable. I think people used to think quality exists on sites only. No, I don't accept this. Yes, it accepts on sites, but not only on sites. You cannot say exclusively quality relates to site. Quality relates to site, that is part true. Quality relates to overall systems, that is comprehensive, you can say. This should be qualitative and reliable. Qualitative means what? That is a point we have to consider and understand. What is after all qualitative, we say? Quality, as I said, relates to systems, design systems. As I said here, design systems. Required for systems here, individual, etc., all that. So here is design systems. Say I design a building or structure. I am given some drawings already by architect, or I draw myself, doesn't matter. I am given some requirement. You have to include this into your design, and then based on that, my conception, which is approved one, I am going to design structure. Now my mind should be clear here. Everybody knows it. Whatever I am going to build or construct, whatever I design architecturally, Though it is by architect, but let us say I am architect, imaginary architect. I have some drawing, I drawn it. Now I have to build that. How to build that? How to build that building? How to construct that building which is given to me? I have designed that. That is what is important. I have to convert that planning. I have to convert that dream which is on paper or in my mind into some product, that is strong enough from every aspect to work for intended duration of that project or that structure. If I am given, I to work on the design, I to produce this building for 100 years. This I have to think for that design even for more than 100 years. This is just concept. But requirement is I have to devise something for me so that can be applied to this building structure. So here structure is a system. I can say structures, which is the technical language, we can say it's a formation mechanism. It's a formation mechanism. It's not one dimensional, it's not two dimensional, it's in all dimensions. It's, you can say, three dimensional. X-axis, Y-axis and Z-axis. I have to design, I have to produce a device, or you can say machine, mechanical we say. When I say formation mechanism, you can say formation machine. This means I am going to work on a machine production, on a machine design, machine which is not mechanical but which is going to serve something. This system which I contemplating, this system that I contemplate has to work like a machine. You can see there are many types of machines in the world. I'm not talking of electrical machines. I'm not talking of device machines. I'm talking of a machine that I have to start. I have to make all parts of this machine. I have to design all parts of this machine. I have to design complete assembly of this machine. And that machine is a structural formation, which is generally called structural formation mechanism. You may name it or you may not name it. It has many parts, of course. You may say it is foundation part, it is column part, it is beam part, whatever, slab part. Okay, fine, that is your name. But for me, this is complete machine. I'm not calling this in parts. Formation machine. This machine I am going to produce so that when this is completed, once the structure is over, other non-structural items would come onto this and sit on this forever and put to use after some time. And I say put to use or occupied at this stage, this assignment of project is declared completed. Got my point? This is whole system for structure. Structural system here. How we do that is different. But this is a structural system. I am talking about this system, and this is one of many systems. The structural system is there. Then there is architectural system also in that. Then there are finishing and roofing, HVAC in that, electrical within that, security also within that, flooring within that, walling and plastering, external, internal rendering, and many other services, plumbing services, or you can say gas services, water services, sanitary services. Means all systems are there. They're all systems, dependent systems. This is also dependent, but independent exclusively, because if this system works well, other systems induced on this or put on this would work successfully. That's why I say it's complete system. I'm talking systems quality. I do not say system quality, I say systems quality. So this is designs of structures. and others. Here is a structure, and there are many others in that. Must be qualitative and reliable. This is what I want to state. What is here? Qualitative. What does it mean? That's point of concern. What does it mean? Everybody may say something. Yes, I'm not talking like infant engineer. You got it? What is quality? I just give an example. To this exclusively personal, but I want to make it public. See, I was too young in 1981. Too young means I was working at that time in Delhi Development Authority, government job, and I worked there for about 6 years. I completed my degree and I was trying to get some overseas assignment in those days. In 1981, when I think I was 26 years something, 25, 26 years. My experience was government one. I never worked with a contracting company. So I didn't know at that time. Some said, you go to government if you're working in government, if you want to go to overseas. But I could not get government job. I could not apply because I had no such source. I used to apply whatever I can see was published, private or no private. I still remember, maybe I can say I was incompetent that time, even after passing Section A and Section B of IEI, Institute of Engineers India. I was a qualified engineer at that time. I passed my 3 years civil engineering diploma in 1974. I had to go. I thought I had to go because I was fed up with government job. There was namely any engineering activity except quantity surveying or estimation like that. Supervision was only for namesake. You can say there was no engineering supervision in fact on buildings. I worked on buildings. There was no engineering supervision. For namesake we were there. Purpose was what contractor does. You have to make payment based on measurements, based on bills. You have to prepare, and that was main job. Or estimation, like that all. I thought that position is good, no problem, but others, sir, they will not have different attitude in life, just like attitude. My commitment was that I wanted to be engineer. I do not explain more on that, but what I say, I had decided that I not inclined to continue this job. I applied many places, and for Iraq or for whatever country vacancy used to come. I still remember one interview, and that changed my thought process. I never thought that this would happen to me in those days. I used to think that I was very brilliant. I was very active in studies. I was very dynamic in work. And I used to argue with people. I used to do everything a professional does. And it was just I was 25, 26, 25, I think. It was when construction company, I can name it, no problem. I don't feel any shame. It was Continental Construction. Its office was located in Nehru Place, Delhi. And I applied for some position there for Iraq. They called me for interview, and I appeared there with full confidence. Oh, I can win this job. I can hunt this job. What is this job? I have so much experience, 6 years experience, and I'm qualified. I'm AMIE. Of course, I was very confident. You can say overconfident. I'm just trying to explain to you what quality is. I worked for 6 years. I argued with people. I then entered an interview. Of course, I never expected what happened here. It took about 1 hour, more than an hour. And They did not raise any theoretical question, not at all. No bending moment, no shear force, no deflection, no, you know, you can say it was like dream questions, dream world. They ask all questions of practical nature. Practical nature, that this happens on site, what shall you do? There's a problem in concrete, what shall you solve it? How will you check this? How shall you check that? They ask me all certain questions I never ever imagined, because I never was exposed to such quality work. Though in those days there was no quality system at all. Quality was considered different way. Means quality controls were only quality. And I never worked at such, because we had controls in government, but those, all formalities. Nobody cares about that. Even concrete cubes were crushed there, and whatever load you can see, your contractor will bring you. See, this is tested report, and this is okay. Means I was never present on those laboratory testing machine, and I think contractor used to pay some money to those technicians, testing technicians, and you know what happened? Believe me, I never knew. And even some people on some sites never even demanded vibrator for concrete compaction. Or I'm giving you something else. People used to sell cement because it's a controlled one. They used to sell steel bars. So I never ever liked to work there. That was the only reason that and there's some economic problems also, you can say, some economical issues and all those. So I had to appear in those interviews. But this interview made me, you can say, I can say, I was very much upset. Means I could not answer their 10%, 15% questions, and they taunted on me. They say, over tank off, did it collapse? What was your contribution in that? It's a astounding question. I was nothing to do with that tank. In those days, some tank collapsed over a tank, RCC tank, and they were asking, what is your contribution to that? Like that, many questions regarding mixer, question regarding water contents in sand, which I never thought of. Of course, I studied, who remembers and who goes into such depth. So I'm just explaining to you that I was, kind of was kicked off. I was, shot in that interview, and that interview changed my life. I estimated myself, evaluated myself that I was nowhere in engineering except theory. Whatever subjects I learned, I studied, I passed. That's exclusively theoretical. There was no element of practical angle, practical aspect into those studies. And my experience was supervisory, means not based on contracting companies, and this company was contracting. So I say, okay, now it's very difficult. I'm just trying to say, my failure was there. It's a complete failure. But this impacted on me, impetus that you have to learn. It's not easy. It was not easy to enter construction field even. I thought construction easy, but I understand now how difficult it is. I then joined another interview and got through that, so that you can say I got an opportunity to start, or you can say break in career. Then I went in another company and tried to again be beaten there, because I never knew how to work in contracting. But gradually, after making many mistakes, after being embarrassed many times, I started learning, and I realized that just theory is not enough. Just theory is not exclusive in engineering. Theory is one part, but real experience is another part, and that's where you have to understand what quality is. sorry. So after that lapse of my selection, I changed my route and oriented myself on learning only, thinking that I leave nothing. That is why from that time, that is 81 onwards, and it's now 21, you may say 40 years gap, about 40 years gap, I changed myself, that my work should be goal oriented. It doesn't matter what I am, I have to learn everything. It's not my degree issue, it's not my another degree issue. Issue is work. Degrees we can study and get, it's not big issue. You can study, you can pass whatever degree if you want, if you can study it, if you are back, if you are economical, no problem, then you can freely study. I'm not criticizing degrees, but I'm not exclusively dependent on degrees for work. So I say designs of structures and others must be qualitative and reliable. That's my question, that's my title. That can degree teach me? Yes, it can teach me syllabus. It can teach me syllabus, indeed. Nevertheless, it cannot make me engineer of work, engineer of target, engineer of production, engineer of quality, engineer of organization, engineering resource organizer, engineer who can think, engineer who can understand value of time, engineer who can understand value of cost, who can understand quality, who can think of everything. That engineer I'm talking, that engineering I'm talking, that quality I'm talking, means one should not be engineer only, one should be quality engineer. One should think of quality criteria all time in every activity. That's what I mean. It doesn't mean quality control, no, I'm not saying that. Quality control is different. I'm talking of quality engineer, that you have to adapt to all disciplines, interactive disciplines. You have to use your mind, not in one specialization. Yes, you have one specialization based on your experience, but interactive disciplinary understanding, interactive disciplinary attainment, or your mind should be that sharp that can grasp every problem and find a solution. Your brain should analyze every issue and use that. Quality, as I say, in structures means quality in structural designs and quality in structural production. Structural designs and structural production, I'm talking of both. I'm not talking of structures designs alone. Yes, designs can be done in varying ways. There are calculations, there are procedures, there are formulas, there are conceptual application, formation mechanism, everything is there. How much economical you do it, and when you say economical, I should not say financial economy, I should say material use economy. Of course it relates to finances, but we have to consider all factors which are given in codes as well as which are otherwise by experience you have. Decision making in designs, and decision making means analyzing designs. Decisions can't be made directly, arbitrarily. You have to relate your decision to circumstances, to actions, to forces, to requirements, to areas, to locations. It's like Eurocode says, international code, which is Eurocode, and also nationally defined parameters, both are considered. So when you talk of quality in structures, I should say quality in design and quality in work. When quality in design is concerned, I should say your design or structural design should be so clear. It should be so simple and clear that it doesn't create complexities on sites. It should be it should be conveniently understood. Yes, your detailing should be so explicit that site guy should do them with warm welcome. It's not necessary how many drawings you should have. It depends upon explanation. It depends upon elaborative details. You should not leave everything to site guy. The best engineer in design is that who understands how best work can be done. So simple. It's not simple, you know. We have to think for design, of course, that's our job, how best we can produce, but we should not forget what is market. For example, if you give unnecessary dimensions which are not required. I have seen somebody giving column dimension 27.5 millimeters. 275 millimeters. Was one engineer. He used to come to me long back when I was in Delhi. He was in government, of course, but he used to come to me for consultants. So he was also an engineer, but he used to come to me, please tell me this, how to do this, how to do that. He told me, I'm getting 275 I'm taking for this. I want to save 25 concrete. Oh my God. I told him, you are taking 275. What's the purpose of this? Why not 300? Simple. It should be convenient for work. What is fine 275? What I'm saying is, similarly, used to take dimension of beams, right? Oh, I want to reduce dimension for economy. That's what I'm saying. Economy is one consideration, but not total consideration. Economy is one part, but not every part. Yes, you take whatever you want, but you have to keep dimensions of section in consonance, in relation to each other. You know, it should be safe first of all, that's okay. But you give some limit of tolerance for that person whom you don't know. That person who is not thoughtful like you are. And I am sure even if best designer goes to site to work, that person won't be successful without experience. You are well experienced in designs, fine. You are, I am, can be. You can deliver best designs. You can explain also. You can give logic also. But you have no experience of that level. That downtrodden engineer who stands in sun, wind, temperature, high, cold, and deals with all-time angry mood and those people who do not know anything, he deals with them. You think yourself in that position and see what level of thinking you change. Can you think like them? You cannot think like the person. That's why I'm stressing the qualitative design. Design of quality does not mean beautiful design, does not mean very complicated design. It should be as easy as possible, as convenient as possible. Simplicity doesn't mean easy calculation. And complexity doesn't mean beautiful design. That is what we have to think. Means how easiest is design constructable. That's one part. Safety is there, of course. Use of your formwork again and again, and ease of pouring concrete, and making it convenient for crew, and also making it procurable without any problem. Means if design lacks all this constructability or buildability, ease of working, or you can say complexities which are not solvable, or you can say there are always complete congestion of steel at this junction, congestion of steel here, we cannot vibrate properly. Yes, this you have to think during design time. Don't leave it to site worker for commenting. You have to keep yourself in mind that you are on site while designing. Don't think you are in design and your job is over. It is your duty as designer to help those people who work. That's what I mean. Reliable, when I say reliable, as I said, what is reliability? As we said there, reliability, I think it's there, yes. Yeah, it's there, reliability. It must be defined and achieved. That is safety, serviceability, durability, and other applicable knowledge areas, factors, resources. Your design must meet this requirement. I'm not saying you won't do it. You would do it. You do it. Everything you know. Even then, we are making intercoordinational talk. This is what, as site person, I require, and you have to give that. And this is not only reliability, also you can say it should be analysis and synthesis based. Let's go back. Sorry, let's go on. Yes. What he was stressing on structural quality means design quality and construction quality. If I get good design, I can do first of all fast construction, and when do fast construction means construction easy and details can be easily done. Means we have to keep in mind shape of formwork, size of formwork, and also detailing of steel bars. And if it's structural work, detailing of structural work. Though structure is not that complicated in structural engineering of steel structure, but because generally members are fabricated, produced in your factory, you have just to assemble, so that's different world. But if you talk of RCC, we have to be very careful about this. We may involve ourselves virtually with site people before work is done. In designs, we have to make it as easy, as comfortable without involving. We should ourselves think, shall it be easily constructible? We have to keep in mind, shall it be repeatable? Or how many use this shuttering can be, how many times, 6 times, 4 times, 5 times. Yes, we have to keep that also in mind, so that economy is considered there as well. If we satisfy these two requirements, that is ease of construction, and our site people keep up quality controls, they understand drawings easily. Drawings are self-explanatory without any lacuna. Instructions are clear, sections are clear, coordinated, duly coordinated. We should not leave for future adjustments. It's not good. Yes, there can be some exception or some copy paste error or some other error where site guy finds some coordinational issues. Those can be tackled by coordination. नहीं तो पूछ रहा है, मैं तो कुछ भी नहीं किया. Our side people, we should keep in mind that they cannot study drawing all time. They study only at 11th hour. This is practical. If you say design, people are also under problem of pressure. Well, I think everyone is under pressure. I worked in designs, not very long, but I did my design myself. Of course, I'm not very expert, but sometimes it is required we do it. For example, I designed my own home from A to Z. I did it myself and worked out. And also in many small projects, I designed on my assignments. Whenever some details didn't come, we did ourselves. And for that purpose, we say on sites, coordination is very important. And of course, site engineers are so busy, I think they cannot conduct coordination so easily. So on projects, you will find coordination engineers or project engineers, or you can say there may be engineering wing who does coordination on sites. It depends on organization. There is no hard and fast law or rule for organization of such issues. Yes, it is duty of designers at least to coordinate designs. If not remaining items, they can coordinate designs at least while doing work originally. Maybe they miss something due to services, but as far as coordination of structure is concerned, I don't accept that. I can say agree that they cannot do it. Structural coordination with architecture must be done, provided there is no change in architecture, and if there is change, then previous drawing must be superseded and issue for construction drawing is issued. Now, issue for construction design or approved for construction, such drawings are very important for designers as well as for site people, because once a designer certifies or seals approved for construction or issued for construction drawings, this means that designer gives allowance to work on this drawing, go ahead. And if there are revisions on that also, no problem, it can be, before work is done. And if work is done, then there's no use of revision, because work is done, you can't change it. If you change it, it's very expensive. So before work is carried out, there can be, you can say, revisions, and these are done, but not enormously. Yet I have seen hundreds of queries, site technical queries I raised because I was in coordination, and these problems used to come to me to sort out, and we handled those queries. But formally, officially, you cannot just decide something on telephone. You can decide ad hoc, but for purpose of commerce and for purpose of recording, for purpose of records, we have to officially do it, because no change can be left unattended. So coordination is very important, engineering coordination, construction coordination, and these structure changes in drawing, you may say, are very important, and this should be done promptly to avoid wastage of time in construction. Sometimes even I had experience also when we were just to pour concrete, a big quantity of concrete for 400 cubic meter, and something came, stop, and British guy came and say, oh, there's some change on this side, hold on this triangle, you see this triangle, means we had to hold that one for one day, and we had to change some steel reinforcement in that foundation. So we lost one day. Maybe one day not good for you, may not be very calculating for you, it's not very critical for you, but for us it was critical. So qualitative and reliability, you understand very well. Your design is safe, it's performer, it's serviceable, it's durable, all that. You're master of that. Design is a master of that. I don't want to point out that one. But more than that, as far as production is concerned, production is very important part of our project. If production is defective, if work is defective, deficient in quality, I can simply say that it's a failure of designer. Of course, it's super failure of site guy, but designer also feels that his efforts have gone in vain, because whatever that designer contemplated while designing, that didn't work. And that's very important part. It didn't work. Why it didn't work? That's different issue, but it didn't work. And work is done. It didn't, design did not work, but work is done. This means you can't change it. Your dream design went in water, dissolved itself, and you have to change your design. And if some further activity is to be done, you have to keep that in coordination so that it meets or is competent or is in consideration or compatible with previous one. That's where lies. You see, we can speak anything, we can write anything, but construction cannot speak, construction cannot write. It depends on attitude of people, it depends on commitment of those involved, it depends on many factors, and sometimes frequent changes on drawings do cause a problem, because you can't expect site guide to know update, and updates keep on coming, and until these updates reach to site, it has been experienced that in many cases works are done, works are over. That situation causes a problem if rework is done. There was a project in Abu Dhabi in 2000, I think 2002, 2002, and I think there were many changes on blind foundations. We used some, then some changes came. Oh, there's different type of machine coming in. You have to change these foundations, either demolish this foundation or amend this foundation, modify this foundation. And, it's happened frequently on that. But they were under agreement. All modifications shall be without cost. There was some condition like that, which forced us to digest everything. So all stages designs, I say all stages designs, but only designs doesn't suffice. All stages designs. All stages designs, but only design doesn't suffice if construction and development are not affected to mark. Design drawings must have quality and duly coordinated details, keeping abreast site working conditions. Again I read, all stages designs, but only designs does not suffice if construction and development are not affected to mark of requirement. Design drawings must have quality and duly coordinated details. keeping every site working conditions. That is important point. Our designs must be compatible with site requirements. There, when we work on fast track projects, of course, everybody remains under pressure, and that pressure, of course, sometimes creates interaction problem or interdisciplinary coordination problems or issues. We have to keep in mind that everybody works for project. Goal of everyone is delivery of projects, while there lies varying difference in roles of everyone. Construction based on reasonable coordinated quality design. Construction based on reasonable coordinated quality design plus plus. All activities must be taken care of. All activities must be taken care of, but it doesn't happen. Construction method statements. A must. I claim, I command, I require. Construction method statement a must. What do you think? Design method is one part that is done with the help of computers, but construction method statement is done based on writing, and that writing is based on procedure, and that procedure is based on your contemplation, and that contemplation is based on your thinking. How best can this work be done? Work can be done in many ways. There's general saying in many books that engineer or site engineer can think one way, or you may say project engineer may think something to do in one way, while same thing a contractor can do in 10 ways. This is general phrasing. If you want to say this work can be done this way, contractor shall explain to you 10 ways, because contractor wants to do some job for his own consideration, while you want to do same job for engineering consideration. There's only little difference. Means goal is same, activity is same, result is same, but a route is different. Now which route we have to follow? Because construction is not done only for contractor, it's done for an owner, it's done for engineer, as far as project is concerned. Therefore, there should be a common statement that directs everybody, that you can say binds everybody to do work one way, and that is this way, which is written on your statement, which we call or name statement or method statement or construction method statement. All parties talk together, consider together, site engineers, project engineers, and whosoever are responsible, they consider together issue of scope, issue of materials, issue of safety, issue of references, drawings, and how to do that, where to check, where to inspect, in between, what to inspect, how much to inspect, and how much trust to be left to site people. That descriptive statement, descriptive not like books, just means every activity is defined that way. Maybe in 2-3 pages one statement can come in, and if it's very long, very big work, which involves thousands of cubic meter, hundreds of cubic meter of concrete pour, it may require plenty pages, like 5, 6, 7, 8 pages maximum, because you have to attach various stages of your arrangements, how you will circulate those vehicles, and how shall you use your pumps, etc. And those sketches I'll share with you later on, but now I can show you. I'll find if I can now. That's where we have to write in our statement. We will do this way and that way, and it can be even grouping of people. How shall we do this? How shall we work on concrete? How shall we pour it? What time we should start, and how it go on and on and on. I mean, it should be comprehensive in the sense that project engineer, site engineer, and your quality people, your workers who are involved, crew, they know what is to be done, what is sequence of our follow-up, and that we can call construction method statement, and it can be done for every activity, from excavation or from survey to all electrical. That is written in form of statement and agreed and approved, and then we have to follow it of compliance. And if you violate that, that's not. You have to decide pre-doing that, not during working hours. That's not permitted. Or if there is some mistake, some error in statement, that is different. Means sometimes work is done, then work is revised in writing, and this keeps on and on. Work is done means we just keep on documentation in quality system, because quality system is documentation is a must. We have to fulfill documents also, because those documents have to be delivered at the end of the project, during handing over time, at mechanical completion or practical completion. So we say, for purpose of carrying out work, method statement is a must. It's a must for purpose of doing job as well as for purpose of record. And we have many method statements I have been using. Actually, this is also a part of method statement. How to control, how to do such thing. It's very small paper, not very expensive paper, but explanation is very important based on experience. And I have seen many writings of people. See, writing is one part of job, but writing should be contemplated. It cannot be simply essay writing or story writing. It should be technical writing with consistency and competent statement. So, expression of details in convenient format for work performance, and define elaborate performance. Means we have to express our working details, so what we want to go, what we want to do, what way we want to do, what way site requires, what way contractor requires, is that right way or not right way, and that engineer has to agree, has to approve, actually not only agree, because without approval of engineer, contractor cannot work. So it says expression of details in convenient format for work performance, and define that, and then also elaborate how shall you perform. This is general behind statement. Now time is an issue, and we know it can't be changed. Time is an issue and it can be changed. It's very difficult to change. Time is very important factor on project. If you lose time, you can't recover it. Time gone is gone. It's very difficult to bring it back. Yes, it can be adjusted but can't be brought. It is irrecoverable practically, and then unchangeable within controls. Now cost. Cost is invariable. Whatever you have agreed, you won't be paid more than that. Yes, there can be escalation or there can be reduction. You can say there may be some items which are not done, or there may be some items which are added. That depends on agreement. Escalations may be there, but cost on lump sum cannot be changed, or budget cannot be changed. It's very, very common common thinking that binding is binding. It's also a part of understanding. It must be understood by engineers that cost is very important factor, which if lost is lost. Means we have to understand contracts for that. We'll talk later on about contracts. Now, risks. See, many escalations and many variations do also cause some problems sometimes. Therefore, there is always defined limit that not more than so many % of cost of this project can be variations or escalations. Then comes point of risks. Risk must be foreseen for resolution. In fact, engineering itself is a risk. Project decision itself is a risk. Without risks, there can be no project, and without risk, there is no investment. But we should know what is risk. We can foresee that. We can have vision of that. And if you have that quite advanced in time, then we can find, after doing analysis of that risk, we can find some solutions, some calculative solutions in advance, so that this risk term is mitigated and this becomes a part of play, part of, you can say, our job in easiest way, that we are going to avoid this risk. And then you can say this is preventive measure, or we can convert this risk into another formation where it benefits us, or it equalizes, or it, you can say, neutralizes its impact on project. That's why I say risk must be foreseen for resolution. Reliability plus comes in, then you can say reliability plus, as I said before, it must be defined and achieved. Definition is not enough alone. It must be achieved. That is important point. It says reliability equal to safety plus serviceability plus durability plus other applicable knowledge areas, factors, resources, etc. We already talked of. That's where it is reliability. And most important, as we always talk of, that is you can say analysis in designs. You can say before design you have to do analysis in theory of structure, and also we have to do analysis in investment. When we do some bidding for some job, we analyze that bid, and when we do some job on site, we procure some material for temporary work or for preparatory work. We analyze cost, we analyze everything, that we should procure material to that extent that it's neither wasted and not fall short of. Neither short of or not that it may not be useful or may not be solved. It should be scrap at end. Means We can't spend cost without understanding, and for that purpose we say this is our budget. How does budget form itself? Automatically you think? No. Budget is formed by analysis of prices of all activities. We have to work out price of every item, every material, resources like machines, equipment, human resources, and you can say whatever expenses we have to spend on that item. That process we do by calculations based on our coefficients or experience or production output, and we can say every item is calculated cost wise and also quantity wise. Cost of every item, which includes material cost, workers cost, machine cost, miscellaneous cost, direct, indirect, etc. we call it, and all such items are analyzed based on real market rates, or what we have to pay, not imaginary rates, and what we have to pay to our workers, our staff, and what expenses we are going to make on hiring equipment or buying equipment. Means whatever way is to be done in construction domain, keeping value of time, keeping involvement of time, and also risk factors, and also keeping in mind safety, health and environment issue, quality control issues, planning issues, other risk factors, time factors, delay factors, all that are kept in mind, and that's known as analysis. This analysis I'm talking is not analysis for designs, analysis for structures, but this is analysis for activities. And this analysis, once we conduct for price based on quantities, all are summed up. All are summed up, and one figure comes in, and that figure is called price of expenses for this work, total work, and then we add our other expenses like profit or etc. etc. That sum up is synthesis, and individual pricing is analysis. So you can say it's not simply in designs and theory, it's also in practical application, or you can say work application, construction application, or production application. Analysis is an exclusive engineering basis. It is an exclusive engineering basis. A must, it is a must, and all problems to be understood by this approach, or by resorting to this approach, which is synthesis, and this is an analytical based engineering result to apply all solutions. Network must reach compatibility level, and here thinking factor is very important, exclusively important, and we must not forget it depends on not one man thinking, one person thinking. It depends on the group thinking, whoever is involved in that group of construction supervision and construction execution both. Thinking means unlimited thinking, and that thinking, first thinking is for site person who is on front line and who does that job, and that thinking should be supported or analyzed further by you can say other thinkers like seniors and also engineers thinkers. So there are so many incumbents involved, competent incumbent, actually not only incumbent, competent, consistent and professional persons are involved on those thinking. In designs there are structural engineers, civil engineers, quantity engineers, planning engineers, material engineers and services engineers, of course architectural engineers. In designs and in site construction, on sites are all classes of engineers who deal with procurement of materials, procurement of human resources, procurement of machines, procurement of hiring machines, procurement of A, B, C, D to Z, all items, output link, subcontractors issues, and whatever time study, time management, time cost management, negotiation management, you can say in searching for subcontractors, like that, there is one way or other. There are so many ways in that process of thinking, and that's what I say. Thinking applies to individual activity as well as to total activities. Which activity we want to do first, which is required first. And also we have to keep in mind that procurement of material takes time. It's not easy to buy material. There are so many materials which are to be included permanently on every project. Those materials or equipments, machines or whatsoever is included are to be procured in time, and there may be variations in market prices. Even after quotations are received in time, there could be fluctuations, but you won't get any change of money, change of variation from your contract, but you may have to pay them. That's also a part of thinking. How to contain that, how to digest that. So that's thinking, means financial thinking, and you can say procurement thinking, work thinking, time thinking, and also contract data thinking. Means every day is very expensive, every day is valuable. Loss of one day is not allowed, loss of half a day is not allowed, loss of 1 hour is not allowed. Projects are like that. Means we want people, we require those people on sites. That's why I say dedicated, devoted, committed, irrespective of duty time, irrespective of working hours, who have committed to do and deliver that project. Such type of people are required without any additional benefit to them, but future benefit to them, because once they work on project, they earn something technically, professionally, and they continue professionally develop themselves. They continue to do something for themselves for future, because learning is very important. As I said in the example, I missed to learn something I could not answer in interview, and that was my loss. But if I had done something there, if I had learned something, then I would have qualified that interview. That's an example I gave. Means such update one should have in works. So we can say thinking and only way. There is no other way. You cannot bypass thinking and say, no, this is a miracle I have done, magic I have done. That's not possible. So thinking consistency comprises of contemplation. Thinking consistency leads to competency of contemplation. Means one part you think, second part you think, then find solution, and then you find connection and framework of those results into contemplation, and then you have to achieve that. And this is all called what you say engineering. Applications must be affected, that is final answer, that is final requirement. If you cannot achieve applications, or you can say work on site, that's application. Quality oriented work on site, that is called applications, means whatever you produce on site that complies with the design requirements and other contract requirements, it's called applications, and that is part of engineering and piece of engineering. And there are so many such pieces, plus 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 on forehead and backhead both, and those are engineering like that. Quality non-conformance product is called substandard, and therefore it is rejected. Means if you have NCR, NCR, non-conformance report, if your product is quality less, quality non-conforming product is called substandard, and therefore it is rejected at that level. At that level it was intended for to be constructed. Non-conformance means engineer is either, means whoever did it, engineer is either careless or ignorant or incompetent one, and therefore redundant personnel, means he's not required, that person is not required, is redundant, means we don't need this person, is not competent one. This means we must change to requirements, we must change the requirements to achieve intended quality standards for universal recognition. We must change to requirements to achieve intended quality standards for universal recognition. Quality requirements checks being a must. Quality requirements check being a must, missing which we have to blame ourselves for quality failure. Checks, quality requirements checks being a must, missing which we have to blame ourselves for quality failure. Engineering means quality application and continuous improvement of quality. Quantity is there. When you say quality application, of course quantity is involved, product is involved. You cannot apply quality in air, you have to apply quality on production. So just we call CIQ for, namely I said, not necessarily find this word, continuous improvement of quality, just like we say CPD, continuous professional development, and this continuous improvement on quality, and that's what systems say, that's what ISO 9001 mandates, that's what Sigma mandates, that improve in quality. Improve in quality means no errors or minimum errors. That's what quality is. Yes, there are errors, but within limits, within definition of limits. After all, we are all human and errors are expected, but every work should not be erroneous due to some error of misinformation, you can say, or due to some other error. Something can be, you can say, granted, something can be given concession of, but not as norm, not as what you think of. It's not like that. So this is what we say, very important statement you have to deal with. Yeah. When I say quality system, when we talk of, as I said, quality system, or people say ISO 9000, for example, that is system, and people claim they work on that, they follow that. See, system design is in our hands. What we write, what we design, and we approve ourselves. And we follow that ourselves, and the third party comes and verifies it at random. But that's our design. We have to analyze that properly. Actually, if we follow a system, product should be according to that. But in real life, this doesn't happen. That's why we cannot solely depend on system direction. We have to use our thinking and devise system which gives quality product. Sorry, I just went to take a glass of water. So sorry for disturbance. So I was talking of quality requirement, and I explained at length what is quality requirement. I think you must have got my point of view. And quality requirement is not alone, it is total. Means method statements are not alone itself. This must be comprehensive. Well, this is quality requirement checks, and I talked to you many of them before, and I posted them also somewhere. These quality checks, requirement checks, which is a guideline only. And if I try to find, if I possible, let me see if I can get to that in file. And that's a good file, I think. If I get to that one, process of method statement, just a minute please. General is my folder, and it's management method statements, and here may be something I can see. Possibly I find that. Let me see if I can find that. Chapters, method sketches. No. This is mass block concrete. This is there. And also here's another one. Let's see. There's another one as well. It is so we have these two statements for this. Just for reference, I'm showing to use what is method statement. Now this is actually attachment to method statement. What is this actually? If you see, it's written compressor foundation concrete core plan. This is section, foundation strip section. This is foundation strip section, and here is plan. This is plan, foundation strip plan. This size you can see whatever it is, means about 2, 4, 5, 10, maybe 20 for 30 meters, whatever it is. 2, and this is 1, 1, 1, 1, 1. It's a massive block because depth is 2 meters. Now these are 1, 2, 3, 4, 5, 6 like that. There are about 50 steps there. This is 1 unit of foundation, and I sketched out to 50 continuous pours. 50 continuous pours. This means these strips 1, 2, 3, 4 like this. In one we say we have to go this way, come like this. These are directions of pour. Continuously we do this, or we do this, or we do like that. As written, if you see plan pump location, Here is concrete truck. Here is pump location. Here is concrete truck. Here is pump location. Here is concrete truck. And likewise here. 1 meter, 1 meter, 1 meter, 10 meter probably. 4, 5, 6, 7, 8, 9, 12 meters. Okay. Which says our plan is we have to locate this pump here and truck here and pump here and truck here and do concrete from both ends, right? Or everywhere it's shown like that. We start from both ends, each layer, right? So I start one layer from both ends, it's filled, then I go to second one and fill, and then come back on first, third, that is, and then go here fourth one, then fifth one, like that. It should move in this way so that no cold joint is established between two layers. No cold joint is established, and that we do 50 layers. Got it? In each layer 9.6 cubic meter is quantity in each this layer I'm saying. So if that 50 means about 400 something, 80 something, 4, 6, 380 something, say 400 cubic meter approximately. We have this concrete, total concrete. This is method we have to do. Why we have to do this? Some people say no, we will do all this, then all this, all this means 5 layers I want to do. No, this is not acceptable. Keeping in view repetition. If I lay this layer up to this layer, when I come back either from here or from here, if I come here, it's a cold joint issue. If I come there, then all here may be hot joint, but there may be cold joints. That is what we have to avoid. That's part of planning we do. Here I say start early morning or late in hot weather conditions. Late evening, if hot weather, you have to do this in late hours. We have to do in late hours. Start early morning or late evening in hot weather conditions. Thermal curing required. We'll discuss later on, not auxiliary curing, because this is big ball. 60 truck tips at 8 cubic meter each. Frequency 15 minutes. Thermal, and then pumps too. One pump is here, one pump is here. Pump means concrete pump. Then 60 trips are required, and form system required. 8 hours are required. We calculated GGBS concrete required, and we need vibrator 6 number here, mason 4, helpers 20, carpenter 4. So we need resources as mentioned. This information is comprehensive. This is 480 cubic meters quantity here written, and there are 6 locations we are going to use this equipment. This is location 1. This is location 1 here. This is location 2. This is location 3. So this is a brief method that gives comprehensive statement along with text. What we have to do, This goes to everybody, and if it's approved, you have to follow this. That's the important point. Means in you can say how many hours? This is given somewhere here 8 hours. No, yes, 8 hours. In 60 trips in 8 hours, so that here batching plant manager or organizer knows how many trucks he has to send to the site with what frequency. Of course, contact shall be kept in for any emergency, but this is information given to that person who deals with production of concrete. This is very important point, that this information you have to work with professional way, and this is a professional way. And also you can say if it is there. Now this is another one. It is same, but it's raft. You can say here. You can say here. You may say this is, like this. This is raft. And section is this of 5.5 each, and these are sequences of this. What's written is step section 125 cubic meter each. Required a number of stoppers for emergency meeting, 28 trucks, mixers, transit mixers, 8 pumps from 2 standby, temperature of concrete 24 degrees Celsius, use ice if required, GGBS required, 70% cement replacement is a must, and site shading with cool air circulation in proposed area, necessary for midday hours, cold joints not allowed, insulate top of unformed concrete surface, spray water on side forms to keep concrete cool, keep raft block in cool area continuously. This is what is here. And 5 meters width, and length, much is that. So I close. And close this also. And you can say this is called some systematic work. Means, as I stress, that method statement, this is a part of method statement. This is just attachment to that, and there is a document with this also, written document that we will discuss. That's very important one. We'll discuss that one also. This was quality requirement I'm talking of, which is based on this quality product, and this is, I have talked to you about various checks, and this is checklist number 1, that is for setting out an excavations. Then there was another one, hand excavation, and there was other one that is for formation, and then for concrete protection, waterproofing, and for preparatory works, that's foundation footings, stub columns, backfill works, grade slab, RCC column works, and of course RCC walls works, RCC walls work, and then also lift well works. I like to show you certain sketches if I can find just now. If I can, maybe I'm lost some time, but I can find. I'll try to get you that lift form. Okay, lift form and wall form both are here. This is lift form, and I just open this. and that is then wall form also, lift form and wall forms, and that is this one here. So I take this also as a matter of requirement, and this here, let us see first wall form. This is wall form. Wall form. Just like this. Just have a look on this. In wall form, I've shown, you can see here, here you can see here, this is a plan. 30 centimeters is the thickness of wall. This is ply, and you can see details here. Type holes. Okay, its details here. See elevation of section of this. This is plywood 20 mm here. Battens 50-75 mm. This is pour platform. This is support of jack support. This is for platform, and this is for wall. 3 supports. This is support for bottom position fixing. This is for 1/3 height. This is for top fixing, position fixing. This is 4 meter height, and you can see 14-ton tie bolts, 14 top tie bolts here, and pipe PVC. Then 0.5 to 1 center. These are generally in 1 square meter. 3 average comes, and this is section here. RCC formwork system, side fabricated. And this is very ordinary sketch. Tie bolts. We have to calculate this also. We have to justify that whatever force of fluid concrete, horizontal force, is transmitted to this system. This system is resistant enough, strong enough to sustain that force, and this won't open. That's where to certify, to calculate. And this is platform. It should be strong enough so that people stand here. This railing, safety railing. People stand on this, work on this wall in all its length. Continuations here. They stand together and they reach here by some other arrangement which is not shown in this. They apply vibrator and pour this wall in layers, and vibrate. This is just indicative one. I'm not explaining how we'll concrete this. And other one, if you say here, this is formwork. The spelling is wrong. It's lift formwork. Sorry for that. LIFT. Formwork. typical site fabricated. This is insert door, internal form, 16 bolts with filling. Okay, now this is left here. Maybe here you don't do concrete, but I am just trying to deliver what is done internationally. It's not simply question of our country, just trying to share world standards. You can see, for example, this is 2.95 years, and you know it's continuous, and here is door of lift, and this door plan is this height is 2.25 meter for this door, and we have to make one box here using these battens and ply, and this box is used for this void. We place this in position and close it. So it's a formwork within a formwork. You got my point. We have to do formwork as whole, and we have to insert this formwork here so that concrete is not placed in this volume, and other formwork are same. You can see this plan of that same, can say elevation B, elevation A here, and this is elevation A, this is elevation B. So this, and this applies this also. B is here, this is B detail, and this is supports like that, and this is elevation A. The spacing is 50 by 50 here, and you can say tie bolt, this tie bolt and this tie bolt at 1 meter spacing, and this is your pour platform. How to pour? You have to pour in these walls here, and this is lift pit. It's below certain dimension, that is 0.8 up to structural level below, from structural level at floor 0.8 meter, and these are walls around. So you can say lift pit in this well, this is well, and we have to work on these sides, all these sides, 4 and 4, 8, and this box we have to work on 8 sides. These formworks, you can say for A elevation and for B elevation, you can say A, of course some adjustment sides here. Then you have to construct this platform here so that this becomes a working platform for pouring. That is my, how shall we pour, that I'll explain later on. I'm just trying to show you a professional sketch. Alright, so this is that one, we'll do it later on. So I close this also. I close this also now. So we can say that we have reached a stage of this lift well valve works item 12. Now let us see how it is done. I explained to you maybe before I did, but no problem, it is issued. And let us say, what is this wall? What is this wall? What I say, checklist for RCC walls works. I'll repeat some item because I made many changes in that later on. So it's no harm if we reconsider sometimes for better understanding. Reconsideration is not purchased, it is availed, you can say. It's in everybody's interest to refresh, review everything. I will review many other items. So now, because I have shown you sketch, I can understand. You may like to review it. It says ensure checklist for RCC walls works. It says ensure structural scaffolding with working platform is in position for access on both sides of wall for preparatory works. You got this, scaffolding is there, which I showed to you. Ensure reinforcing bars fixing is correct to requirement. Overlap should be fixed correct to meet specification requirements. Lowest links should start at half of spacing location from relevant structural flow level. That is lowest link. You know what does it mean? Lowest links should start at half of spacing locations from relevant structural flow. Means I showed to you that. Now ensure reinforcing bars be well tightened and maintained in plumb. Ensure that all U-shaped bars are even. If so required, rings, struts are rightly fixed in position and well secured or anchored. Ensure reinforcing bars are clean and free from rust. Ensure sacrificial anode is fixed, if so required, per design. Ensure touch-up paint, that is epoxy touch-up paint, is applied in case of epoxy coated reinforcing bars when no cathodic protection is designed for. Ensure that for cathodic protection, surety to work. Electrical continuity check is a must around all reinforcing bars. Ensure electrical and other required inserts are fixed and approved. Ensure all concrete spacers are placed in position on both sides. Try to avoid excessive spacers within wall main body if not so required. Check that these spacers are fixed on top portion out of top of concrete pour. Got it? I'll explain. Check that these spacers are fixed on top portion out of top of concrete pour, means at level of concrete if it's placed above that, so that we can take out them and purpose also serve. Ensure all inspections conducted before closing reinforcing bars by formwork. Check whether or not starter or kicker is convenient. Preferably, it should be avoided. If feasible to go ahead without it, using external confining to formwork. Got it? If you can avoid kicker, you can if you hold your shape of wall or column from bottom. There are many ways. Check forms are fixed in position correctly. Check side supporting system intact at one side when tie bolts are used. If you use tie bolts, one side support may work. Check grid offsets, thread lines are available. Grid offsets, thread lines for purpose of measuring distances of ply from that axis. Means you have to take say 1 meter from axis, then you can say take half thickness of wall, then ply, then battens, like that. What should be measured, that should be measured. Check tie bolts are fixed preferably inside of wall section. Tie bolts means inside because there is no other way. In columns you may put outside, but in walls you have to put it inside in pipe. Check that those bolts pass through plastic sleeves with bosses at ends. Do not tighten them immediately, but after ensuring locations and plumb. Top inclined support is meant for keeping forms in position. Middle support located and fixed at 1/3 from bottom is meant for resisting resultant fluid pressure during pour. Bottom horizontal support is meant for holding formwork foot. Check whether or not heavy plumb pops are hung from top of forms on at least 3 or more locations depending on length of RCC wall. Heavy plumb pop means either use heavy concrete piece or brick, etc. Binding wire can also be used to hang heavy weight. Timber projected piece can be fixed on top to hang suspend bob. In case proprietary system is used in place of site fabricated one, check that system is in line with system manufacturer drawings requirements. First check form location at bottom, then at top. Check location somewhere at middle. After ensuring form locations, check plumbs on all locations, vertically on full height casting. Check for adjustments if so required to bring errors within permissible limits. Once forms are checked for horizontal and vertical location, start fastening ties and ensure supports are well anchored. Having completed various walls preparatory works, move for working platform operations and check stability of system. Plan for inspection and concrete pour. Check adequate working space is available within wall preparatory works. About passes of pump pipe down to at least 1.5 to 2 meters above lowest concrete. Starting a reducer is required at pump steady, as it has to be poured in rotation of heights not more than depth of nozzle. It would risk opening forms in case pour is allowed fast. Wall is not an element like columns or beams, and therefore it imports a good check and site attention. Wall, I can say, is little complicated if its thickness is width is less. You call it thickness or you call it whatever you call it. Walls, if for 150 mm difficult one, it's even 100 mm, it's much more difficult. You have to be very serious about wall issue. I'll explain about lift next time, because then suspended slabs I have to explain. I have to explain this wall I explained today. You can say last suspended slab, no. This wall I have to finish first. Longitudinal stages we did. Then we can say also lift well. Okay, lift well I see. And this is RCC wall was item 11. And we see here RCC column works. Let me just repeat column also, it's also important one. Though we did before, yet it's not bad if you do it now. It is that ensure site scaffolding with working platform. Ensure site scaffolding with working platform is in position for access around columns for preparatory works, just like wall. I will column also. Ensure reinforcing bars fixing is correct. Be fixed correct to specifications. If mechanical connectors are defined, or couplers, you may say, mechanical couplers are defined in place. Location from relevant structural flow levels. Ensure reinforcing bars should be well tightened and maintained in plumb. Ensure reinforcing bars are clean and free from rust. Ensure sacrificial anode is fixed. Sacrificial anode, that particularly aluminum construction, as I referred you cathodic protection paper that it is used there. If so required for cathodic protection, when epoxy coated bars shall not be required. These cathodic protection can be fixed on non-epoxy coated bar or carbon steel bar, you can say, without coating, so that electrical continuity check is done. Ensure that for cathodic protection surety to work, electrical continuity check is a must around all reinforcing bars, where each bar has C-clamp and GI wire moves on that on each bar, and complete circuit is done connected to anode. So electrical continuity check is must around all reinforcing bars if cathodic protection provision is made on time. Ensure epoxy touch-up paint is applied in case of epoxy coated reinforcing bars have been included in place of ordinary non-coated bars. Ensure electrical and other required inserts are fixed and approved. Ensure all concrete spacers are placed in position. Spacers or concrete covers, you can say. Try to avoid excessive spacers within column main body if not so required. Check that these spacers are fixed on metal.